Okay, so this is what you're supposed to do lah. You have to do this on your own. Don't look at the solution. Solutions are sometimes confusing. Try to do this on your own first. If you're having trouble, yeah, you can look at solutions. So far we've done some examples on projectile motions. This one, what is it about? R, range, height, sama je. Determine the speed at which he was traveling off the slope. This is nice. Okay. We're trying to find the speed. The rider jumps off the slope at 30 degrees from a height of 1 meter. So original height is S naught Y is equal to 1 meter. Sx, don't know. Determine the speed at which he was traveling off the slope. The horizontal distance he travels before striking the ground. So kena cari speed and you have to find horizontal distance. You need to find V and you need to find horizontal distance, Sx. So as usual, probably you wanna write down your equations, right? So the first equation 1, V is equal to V naught plus AT. S is equal to S naught plus V naught T plus half AT squared, and finally this one V squared. V naught squared plus 2A S minus S naught. So these are the equations lah, which we tell that this is equation 1, this is equation 2, this is equation number 3. So let's solve this one. Definitely we're gonna be looking at horizontal first. So horizontal, this is the only thing which is important. We're gonna be looking at this one. Only thing is there is no acceleration for horizontal motion. So let's check it out. S is going to be translated as, obviously, Sx. S naught x plus V naught x t. That's it. Sx berapa? I don't know. Nobody knows yet. Leave it be. Original displacement, definitely it is 0. V naught xt, don't know. V naught x tak tahu, tapi t tahu. 1.5 second, 1.5 second. So Sx is equivalent to V naught x 1.5. So this is important equation. Keep it. Next, we're gonna solve vertical. So obviously, V naught x is equivalent to V cos 30 degrees. This is 30 degrees. This is V naught x. Okay, obviously, we need to consider horizontal component only. So when we're talking about vertical, V naught y is equivalent to V sine 30 degrees. Obviously. So let us solve this one. Which one? So for vertical component, everything can be used. Okay. First one, second one, third one also can be used. So which one should you be doing? I'm not sure. Probably not the first one. The second one, do you know any information on V? You don't know, right? You don't know information on V. You have no idea. Definitely it's going to be the second one also, I think. So Sy S naught Y plus V naught Y D plus half A T squared. So how to solve this? S naught Y. Do you know that? Yeah, we know. Original height adalah 1. Final height adalah 0. Because why? It drops on the floor. We take 0 here. So V naught Y tahu tak? We don't have the value. V naught Y tak tahu. T tahu. 1.5 plus half negative 9.81 T squared. But T you know already. Let's plug in T. 1.5 squared. So what can we get from here? 1 plus 1.5 V naught Y. Ini tinggal berapa? Tolak lah. Minus. So let's solve this one. 1.5 squared times 9.81 bahagi 2. It's a negative and the value is 11.04. 11.04. Bring this over there, you're gonna get 1.5 V naught Y equals 10.04. Okay, bring this over there, becomes a positive minus. So definitely lah, you're gonna get V naught Y equals minus 1 bahagi 1.5. 6.69 meter per second. So ini V naught Y. So you need to plug in this one. What did you get here? Plug in here. So what do you get? 6.69 equals V sin 30. V sama dengan bahagi sin 30. 13.38 meter per second. So this is the velocity of the motorcycle. Check answer. 6.69 V naught Y, VBX, VBY. We get this correctly. Let's try to plug in here. Sx sama dengan V naught X. V naught X berapa? 13.38 cos 30 degrees kali 1.5. Berapa Sx? Cos 30 kali 1.5 doesn't make any sense. All this is wrong. Where did we make mistake? Did we miss out on the time? Time is correct. Horizontal. Immediately he knows. VBX, VBY, height. H pun tahu. Since the type of flight and the vertical distance between the ends of path are known, we can define VA. YB. -1 and 0. VA sin 30. Sama je ni, silap kira ke? It look okay. Probably we didn't calculate properly. V not Y 6.69. 13.38. Yeah. V not X, betul? This is correct. Velocity is okay. 13.38 here over here, right? VA. VA is actually correct. How about displacement? Let's check out the displacement. Sx is equal to V naught X kali 1.5. 13.38 cos 30 times 1.5. 13.38 times cos 30 times 1.5. 17.48, sama je. So betul lah. 17.38 meter. This is the range. 17.4 meter. Okay lah, correct lah. Finally, over here, it tried to find the maximum height. So find maximum height, you can use equation number 3. Wanna try? So this one can be used to find the maximum height. You can try this out lah. So everything is okay. Yeah. Next. This one looks pretty simple. There's nothing weird here. This is Sx. Or S, no, yeah, this is Sx, final. This is S not Y. This one is Sy. Sy is on the floor. Sy is equal to 0 lah, final. S not Y is equivalent to 150 meter. This one 0 meter. Yeah, you can do this one. Clearly you can do it. How about the last one? The last one is a projectile motion. Now you have a skier. It jumps off like that. Jumps off at an angle. You guys see clearly? Only thing that you need to take care is that once he jumps off, this is Sx, okay? Don't get confused. This is your Sx. Where is your Sy? Over here to over here. This is your Sy. So you need to find out lah. This one is 100 meter. Use the gradient lah, 3, 4, 5. Dia suruh cari apa ni? The skier leaves the jump at theta is equal to 25 degrees. Hits the slope at V. Find the skier's initial speed, VA. Cari VA. So it's almost the same. You can check it out and try to do it on your own first. Then look at the answer. So you should be doing more tutorials lah on projectile motion. And we're gonna move on to the next one, which is something called dependent motion. So dependent motion is motion which is dependent on something else. For example, you've got block A and you've got block B. If block A travels down by 1 meter, Block B also will travel up by 1 meter. So the ratio is 1 to 1. 1 to 1. The ratio is 1 to 1. If block A travels by a speed of VA 2 meter per second, block B pun naik atas samalah, 2 meter per second. So these are called dependent motion. So this is the simplest form lah. So if you derive it properly, you're gonna see something like this lah. This is done by looking at datums. So let's try to understand this. Okay, so let's take a look. So in this case, look at the cable length. This is the cable length. The total cable length is L. So at any given condition, tak kira A turun bawah ke, B naik atas ke, length ni mesti sama. The total length will be equal to certain length lah. Kalau 5 meter, 5 meter lah. Same thing. But take a look at SA. This is your SA. SA, if this thing goes down, SA will lengthen. It will become longer. SB will become shorter since it goes up, right? So SB will become shorter. So length remains the same. So once SA travels down, you can differentiate dSA over dt. So this is what it's doing lah. dSA over dt plus dSB over dt is actually this. Total length is equal to SA campur SB campur ini CD. Okay, let's look at this properly again. Total length ini panjang kabel ni SA campur SB campur ni kabel yang hujung ni CD sama dengan L. So bila SA turun bawah and B naik atas, you differentiate, right? When you differentiate, you get something like this. You get dSA over dt campur dSB over dt. CD ni constant, L pun constant, 5 meter. CD ni mungkin, I don't know, maybe 0.35 meter ke. This circumference kat sini. Wherever the motion goes down or up, CD distance remains the same. So if something is constant and you differentiate over time, no change, so it becomes 0. This one also becomes 0. So that's why it becomes like this. So dSA over dt is actually, this one is actually VA campur VB is equal to 0. That's why you get like this. You bring this over here. So you get VB is equal to negative VA. This negative is just telling one is going to get bigger, one is going to get shorter, or the other way around. So this negative is just telling you on the opposites of motion. So this is how you solve it. So even if things get complicated like this, look at this. Whatever happens, the total length will remain the same. Let's say L panjang sikit kan, let's say 10 meter. Whatever happens, B drop down, A travels to the left, whatever happens, panjang kabel mesti sama je, 10 meter. So that's the thing that we are looking at lah. So the things that which is more in motion, you gotta identify certain datum. So these are the datums lah. So let's look at this cable. The length of the cable L is equivalent to SB campur SB. So 2 SB. And then this one constant. Constant tak payah masuk lah. This one also constant, tak payah masuk. And then this guy H, and then you have SA. Why is it 2SA? It's actually not 2SA ni. It's actually 1SA. This is wrong. This is wrong. I will alter the lecture notes. It's only 1SA only. So look at this. This one becomes H. H is constant. No change. Whatever happens, H remains the same. So that's why H is eliminated. So you've got 2 VB, negative VA. This one is not 2, this one is only SA. And finally, if you look at acceleration, the ratio will be this one lah. 2AB is equal to AA. Meaning what? Meaning AB is equal to AA bahagi 2. Which one is slower? Which one is faster? Maksudnya 2AB baru sama dengan 1AA. Maksudnya B is slow. Why slow? You need to look at this one lah. Dia ada 2 loop. So B is 2 times slower. Like that. So look at this, the last one. If you look at the last one, again, cari length. 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 Sama dengan apa? Oh, of course, you have to determine datum first. Length dia adalah SA campur, ini constant tak masuk, constant tak masuk, constant tak masuk, ini pun constant tak masuk. Ya, length sama dengan SA campur 3SB. SA campur 3SB. VA campur 3VB. Kalau AA campur 3AB. These are the ratio. So this is what we call dependent motion. So you can look at more complicated examples where you have a lot more cables. Study this one. Study this one. Even this one also study when you have a lot more cables. Okay, this is the time for you to do exercise. Determine the speed of block D. Block D. Kalau A turun bawah 3 meter per second, D ni apa jadi? Tentulah dia naik atas kan. But at what speed? Slower or faster? So this is what you are trying to determine. So let's do this. Number 1. Step number 1. Determine a datum. This is a datum. Datum is a reference. So this is your SA. This is actually, you can give it a name. This is D, right? So you can give it a name as D. So length of the cable sama dengan apa? SA campur 1, 2, 3 3SD. So DL over DT. Length tak berubah, kosong kan? So dapat DSA over DT campur 3DSD over DT. Easy case ini jadi 0. Ini jadi apa? VA campur 3VD. Ataupun VA sama dengan negatif 3VD. Inilah jawapannya. Negatif ni nak tunjuk one goes up, the other goes down. So the ratio is actually VA is equal to 3VD. If you don't consider the direction, choose this one. VA 3 meter per second. VA is 3. Is this correct? Doesn't look correct, huh? But let's check it out. VA sama dengan 3. VA 3 sama dengan 3 VD. So VD sama dengan 1 meter per second. Okay, correct. Okay. This one macam sama je. Datum 1, 2, 3 sama je. VB sama dengan 3 VA. Directly dapat. Ini pula 1, 2, 3, 4. Senang lah. VF sama dengan ni A kan, ni A kan. So sama dengan 4 VA. Tengok pun boleh So yeah, that's all for dependent motion, and we have last one lah, which is relative motion. So we'll continue. So let's continue with our lesson. So this is the final part lah on the topics of so far we are learning dynamics, and the first topic that we are learning is something called kinematics. So kinematics, we study about motion, all the properties, displacement, velocity, acceleration. Yeah, there is no force, right? We haven't touched any force, no force. So this is dynamics, kinematics, last topic. What is it about? It's something called relative motion. It's when you have, I guess, two objects moving. Let's say this object is moving at 5 meters per second. Another object is traveling at 10 meters per second. So if you are inside A, this is A, this is B. When they are traveling together, what happens? Okay, so you have to look at something called relative. This is how you look at it. So let's say, yeah, we have some examples here. There's a guy here, C. This guy throws a ball. So the ball is moving. This guy is trying to catch it. This guy is also moving. So what is the speed of B relative to A? That's the thing that we're trying to find. It is very problematic if you have two objects moving. Another example. So this is an aircraft carrier. This aircraft carrier is traveling at 50 km per hour. And then you've got airplanes. This aircraft is trying to land on the 50 km per hour speed carrier. So what should the speed be of the jets so that they can match with each other's speed and can land properly? So it's a different story lah if you're on an airport, right? Airport is not moving. Airport, it is stationary, it's not moving. If you slow down, if the aircraft, if the landing speed is supposed to be, let's say, 100 meter per second landing speed, it's the same case lah. So the landing speed, let's say you want to maintain 100 meter per second, and this ship, your airport is moving already. Your airport is running away. So you have a problem, right? This airport is stationary. Stationary. This is not going anywhere. This airport is running away. So you have a big problem lah. Let's say you want to maintain 100 meter per second landing speed. Let's say. Kind of fast, 300, 100 meter per second. This is so fast. Probably 100 kilometer per hour. Let's say the landing speed is 100 kilometer per hour. 100 kilometer per hour. So, should the aircraft land at a slower speed? Let's say, this is case A, this is case B. For case B, it is direct to the point lah. Case B, aircraft speed should be 100 km per hour. Done. So what if the same aircraft lands at 100 km per hour at a moving target, and the target is already traveling at 50 km per hour? So what is the story here? Is he going to drop in the ocean? So this is something called relative motion. Is there anything here? Okay, you can read what this is all about. Another simple example would be, let me open up. Let me open up a screen, white screen. Let's say you are on you're on the road. Where are you? This is a road. Okay, very big road. So this is your car. No, this is another person's car. This is you. This is somebody else. Somebody else. Where are we? We are at a stop. Stop. So this is probably you. This is the other guy. So both of them are stopped. Why are they stopping? It's at a traffic light. Traffic light. So he is stopping. You also stop. You look at each other. You look at each other. And then he moves. Have you ever encountered this? The moment he moves, you will feel like your car is going backwards. And then you grab your handbrake. So the effect of when he moves, you feel like you are reversing. This is the effect of relative motion. Even though you are not moving, he is going forward, you will feel like you are reversing. This is something called relative motion. You feel it everywhere. Okay, so this is the explanation of relative motion. If we were to derive certain examples, so you have to look at this is a fixed observer, this is a translating observer. They are both. What is this? This is looking at B. And this is a formula. So definitely you will never be able to understand something like this. Let's add one more screen. Okay, let's do one more screen. Let's make you understand. Example. Relative motion. Example of relative motion. Okay, so let's say you are on a very big ferry. So ferry Pulau Pinang. So you are on a big ferry. This ferry, let's say it travels at 20 km per hour. It is moving, So you are on a ferry. Let's say you are riding a motorcycle. This is your motorcycle, or souped up motorcycle. Okay, the ferry is traveling at 20 km per hour. Let's say ferry, we give it a name. Ferry is A, you are B. So, so VA, what is VA? VA is 20 lah. 20 km per hour. Any objection? There is no objection, huh? So VA speed 20 km per hour. You are at the back of the ferry. So now you start your engine, you start your motorcycle, you travel forward. You are traveling at, let's say, 5 km per hour. You are VB. You are traveling at 5 km per hour on a ferry which is moving at 20 km per hour. So what is VB? So what is this? What is VB? This calls for your understanding of relative motion. So relative motion is even important if you're an pilot, anybody lah, right? Let's get back here. VB berapa? Is it 5? VA is definitely 20 km per hour. Is VB 5 km per hour? The speedometer says so lah. The speedometer on your motorcycle is it's traveling at 5 km per hour. But if you are on the beach, let's say you are on the beach, somebody else lah on the beach. Siapa on the beach? Probably some sort of policeman. He has a gun. What kind of gun? Doppler gun, I think. This gun it has a laser, so it shoots. It shoots a laser to the motorcycle. Berapakah speed yang dia measure? What is the kilometer per hour of this policeman? Berapa? What is the reading? It should not be 5 km per hour, right? Why? You are traveling at 5 km per hour, but your 5 km per hour is actually relative to the ferry, not relative to the what? To the beach. To something which is not moving. So the policeman will see that you are traveling at actually 25 km per hour. Why? The ferry is already moving at 20 km per hour. Definitely, you add 5 km per hour. So actually, the reading here should not be VB. The reading for VB should be not 5 km per hour. It's actually 25 km per hour. So this is something called relative. So let's derive it. So VA should we write it like this? Or should we write VB? VB is equal to VA plus VB relative to A. Betul ke? Are you okay? VB. So there are two things lah. VB ni siapa? VB is your motorcycle. VA apa? VA adalah ferry 20. VB relative to A. A kan ferry, B kan kamu punya motorcycle. This is 5, right? So now you get 25. VB. So you have to understand one thing lah. VB is something called absolute. This one is something we call relative. This is what you should understand. So kalau VB sama dengan VA plus VB over A, that's the thing lah. I think we need to add more examples. Let's do one more example. Screen. White screen. Another white screen. So let's put it down. VB sama dengan VA campur VB, tapi relative to A. Kalau nak cari VA pula, VA sama dengan VB campur VA, relative to B. Terbalik. Boleh tak faham? So it has to be, if you don't remember, draw this thing only lah. If you don't remember, just draw this and this. Ini apa? Ini absolute. Ini apa? Ini absolute. Ini pun sama, absolute. Ini pun sama, absolute. This is relative. This is relative. So kena letak something else lah. You gotta put B over A, A over B. Okay, are we okay? So write down in your notebook. This is very important. Where were we? Ferry, right? This is your first case. Ferry traveling at 20. Ferry is A or B? A. Motorcycle is called B. B is traveling at 5. So, look back. Which one do you want to use? Boleh guna dua-dua ke? Boleh aja. I think you can use both. Nak cari apa? VB. Gunalah first equation. VB sama dengan VA campur VB relative to A. Kenapa VB relative to A? Sebab motorcycle dia berada di atas ferry. So it's relative to A. Tapi absolute velocity dia 25. So that's the thing lah. So let's say second case. Second case. Ferry, the same ferry. Kamu dah pergi depan. You are here B. Ferry is still travelling at 20 km per hour. 20 km per hour. Same. Cuma sekarang kamu reverse. Kamu reverse by 10 km per hour. So soalan. Ini kita settle kan? Ini pula. Apakah soalan dia? What is VB absolute? What is the absolute velocity of VB? Guna je whichever equation. Of course, I think you use first equation lah. VB is equal to VA campur VB. Tapi VB ni relative to A. That is the equation that you use. This one. VB tak tahu. Equals VA. VA berapa? 20 plus 20 plus berapa? Negative 10. So dapat 10 lah. So VV is equal to 10 km per hour. So that's the thing lah. To the right is positive, to the left is negative, as usual. So let's check out the equation. Page up, page up. Did we just derive this? Yeah? Hold on. VB is equal to VA campur VB over A. Betul? Betul lah. And if you have acceleration, use the same thing lah. AB is equal to AA plus AB over A. Okay, same case. If you have let's say 20 kilometer per hour at let's say 30 degrees, ada I, ada J, right? So you have I, you have J components. So you have I and you have J components. Okay, hold on. Okay, we are back with relative velocity. So the formula is very easy to derive lah. Which formula you should remember? Let's do this one. This one you can study on your own. There's not much lah. Let's do this one. Two airplanes A and B traveling with the constant velocities shown. Or is this one easier? This one lah. Let's do this one. So number one. This is A. This is B. A punya vector is like this. What is the value? I guess I should break it down, probably somewhere here. Here is good. Okay. This is the vector. 650. Nah, I don't think I should draw. It's already here, 650. This one. This is the vector. How much? 800. Huge, huh? Airplanes travel very fast. This one, 650. This one, 800. This is A. This is B. What are the angles? The angles between them is 650. No, 60. The angle is only 60 degrees. So apa dia nak tahu ni? Airplane A and B traveling with constant speed velocities shown. Determine the magnitude and direction of the velocity plane B relative to plane A. Okay, this is kind of hard to understand also sometimes. Magnitude and direction of velocity plane B relative to plane A. Velocity B relative to A. Macam itulah. So, velocity B relative to A. So, there's a big question here. Siapa tengok siapa? Maksudnya pilot A tengok B ke pilot B tengok A? This one. Velocity B relative to A. Do you get this? So maksudnya in easy word to understand is this one is pilot A look out the window and nampak aircraft B is traveling at speed. This is the thing lah. Maksudnya pilot A kalau dia tengok dekat aircraft tu, dia nampak B ni punya vector arah dia berapa dan berapa speed dia. So this is what it's trying to determine lah. So if you're in electronics, you are doing radar surveillance. So radar will pick up pings, ping, ping. It will pick up vector. If you are on the aircraft, radar nak baca macam mana? So you have things like apa? Collision avoidance system CAS. I think TCAS kot. You have to look read back Aircraft there is a system called collision avoidance systems. You want to avoid aircraft from intersecting each other at certain speed when they are en route. So they have to study things like this lah. Okay. So make a note lah. This is the thing that you have to understand. I guess now we can solve it now. So I'm going to have to rub it off. I think we'll do 1 or 2 examples is enough already. You get the point. The point on relative velocity. So, what are the formulas? Senang je. VA is equal to VA campur VB. VB is equal to No. V campur V. Ini A dah. Ini letak B lah. Kalau ini dah B, ini letak A lah. Ini letak apa? Ini letak A kan? Ini letak apa? Ini letak B kan? So ini dah A. Ini mesti B, lepas tu A. A, B, A or B, A, B. Cuma belakang ni kena letak relative to what? Relative to A. So this is the formula that should be, you can derive on your own, right? So either derive it on your own or memorize it. So mana satu kita nak pakai? Dia suruh cari apa? Dia suruh cari velocity plane B relative to plane A. So dia suruh cari VB relative to A. So you gotta use this formula. Use the second formula. So use this formula. So very easy lah. VB sama dengan apa? VB macam tu So VB you have to break it into vectors lah. What kind of vectors If you're still not comfortable on this, the other vector. Ini vector. Kalau ni 60, this should be 60 also. Are you guys comfortable with this? If you are not comfortable, how this is the point 650 like this lah. And this is 800. If you are not comfortable, 60 is like this car. This is 60. This is 60 lah. Like that. Okay, this is what is this? This is A. This is B. So now the thing is, you gotta break it up into vectors lah and use the second formula. So VA sama dengan apa? VA senang lah. VA is equal to 650I. Right, properly. 650I VA. Settle. VB berapa? VB sama dengan to the left and to the bottom. Dia ada I dan dia ada J lah. The vector will be like that. So VB will be how? Negative 800 cos 60i tolak 800 sin 60j. This is the thing ah. Tak cukup tempat pula. Okay, let's do it properly. The formula VB equals VA plus VB over A. There you go. VB berapa? Panjang lah pula nak tulis kan. Negatif 800 cos 60i tolak 800 sin 60j equals VA berapa? VA senang 650i campur VB over A. VB over A tak tahu kan? So terus dapat jawapan lah. VB over A, which is VB relative to A, sama dengan 650i. Ini bawa pergi kiri. So what do you get? Let's punch in your calculator. 800. Oh no. Can you guys see? Okay. There are some perks to it. Apparently only equation 2 you can see. Okay, I'm going to write down. Equation A ni. Equation 1 would be VA sama dengan VB campur VA. Bawah dia B lah. It's the other way around. Okay. Okay. We're almost there. 800 cos 60. 800 cos 60. 400. Negative 400i. Tolak 800 sin 60. 800 sin 60. 693. 693j. 650 bawa pergi kiri jadi negatif tolak 650i. So continue. Negative 400, negative 650. Negative 1050i tolak 693j. So this is the answer lah. This is the final answer. Okay, final answer. But this is not magnitude. Magnitude macam mana? Okay, draw this one. So kiri 1050, kiri panjang sikit lah. Bawah 693. This is the magnitude. Magnitude dia berapa So campur lah. 1050 squared campur 693 squared. Square root dapat 1050 squared plus 693 squared square root 1258 kilometer per hour. So if the pilot look out the window, it's going to see, oh, this aircraft is traveling at 1258 kilometer per hour. And what is the angle? Kata dia nak check angle ni, theta ni. So this theta will be tangent -1 693 over 1050. Theta sama dengan 693 divided by 1050. Shift tangent 33.4. The angle that the airplane is actually traveling, it looks like it's traveling at 33.4 degrees. Macam tu lah. Walaupun dia macam tu, berapa angle dia? Walaupun dia 60 walaupun 60, it look like it's traveling at 33 degrees due to relative velocity. Two objects moving. So this is how you settle relative motion for both objects moving. So this one is simpler lah. I guess something that you should not forget is macam mana nak tulis this formula. VA is equal to, kalau ni dah A, ini mesti B lah, campur VA. Kalau ini dah VB, ini tentulah VA plus VB. Mesti macam tu lah. ABA, BAB. This one relative to what? This one relative to A. This is the only thing that you should remember. Actually, you have derived this using the ferry punya analogy. So this one is easy to be solved. Determine the velocity of car B relative to A. Car B relative to A. Senang je lah. VB relative to A. Which one? This one. Because of this. So this one you can do on your own. So this will be very helpful lah. If you are designing things like collision avoidance, radar technology, things like this. Nowadays, we don't have these things, Yeah, now they have, right? Now they have things like Tesla cars. They are equipped with radar. They are equipped with radar already. So you have radar. You can detect moving objects around you, and they can project whether you're gonna have a collision or not. So the better it is, So all these things are based on this one, relative motion. Okay. This one also you can do. Yeah, I think we're done. Okay, so that's it for the first chapter of dynamics, which is kinematics. Keep. File remarks recording.